evening and welcome to Space Oddities. How is everybody? And thank you for joining us on this Tuesday evening. As always, if you're new here, then you're especially welcome. We hope you'll stick around and see what we have to offer you. We're a bit thin on the ground tonight because Daz is on holiday, Michael's on holiday, Tom isn't. Oh, Tom isn't. I don't know where he is. But anyway, not to worry. We will persevere. So joined this evening by just Michael and Lou. Good evening, gentlemen. How the devil are you?
Well, I'm pretty good. How are you, Michael?
Oh, I'm fine, Fred. Oh dear.
Yeah, let's.
I don't know.
Just so there can be no mistake, let's just clarify things, shall we? So there we are. So there we are. Definitive answer. Okay, so we hope you've all had a fantastic week. We certainly have. It's very, very hot and humid and sultry here in Spain at the moment, which is a bit of a killer. But never mind, I'm not complaining. Yeah, good week. And Lou and Roger, I trust you've had a good week.
Yep, not too bad.
Good,
Yes.
good.
Life is great.
So, on this evening's program, the main feature, Lou is going to be doing the homework that he was meant to do last week, but actually ended up doing quite a different homework. You wouldn't have got away with that at school, Lou, I tell you. So he's going to be looking at the differences between the Europa Clipper spacecraft from the US and the European JUICE, the Jupiter Icy Moons Explorer, both currently on their way to the Jovian system to investigate the moons of Jupiter. So Lou is going to be doing the battle of the Jupiter explorers, telling us about each spacecraft and the differences and the similarities and what they hope to achieve. So that's going to be really interesting. Also this evening, Roger is going to be telling us a little about astrophotography, because in your comments, one thing that has come up quite a few times is that you would like more astrophotography. So Roger is more than happy to oblige, of course, and he's going to be talking about some astrophotography. Also, a couple of weeks ago, we celebrated our 3rd birthday, and Space Oddity Kareem Jaffa sent us a video from Canada, and we weren't able to play it at the time because of technical problems, but I've now resolved those. So we're going to have a look at his video a bit later. And of course, we've got the usual things. I'm afraid there's no Einstein of the Week this week. Sorry about that, but I just haven't seen anything that was worthy of inclusion. I've seen lots of lunacy, but nothing that stuck out as the usual batty madness this week. So I'm sure there'll be some for next week. Also, because Michael's away, there's no Constellation of the Week this week. So we'll do that next week. And that's about it. So first of all, of course, the usual things. If you'd like to support Space Oddities, you may do so in a few ways. You can click the super chat icon underneath the chat window, the one with the $sign on it, to make a donation directly to Space Oddities. And of course, you can also buy us a coffee by scanning this QR code, which has just appeared on the screen, or you can click the link that's just appeared in the chat. And as always, any money given to Space Oddities, for which we are eternally grateful, goes towards keeping the channel on the air and doing things and hopefully expanding. So thank you so much for any money you can spare to help us survive, basically, because as I always say, we have bills to pay, like every YouTube channel has bills of one sort or another to pay. So it all goes towards those. Also, don't forget that it's T-shirt season, and you can get your Space Oddities merchandise, T-shirts and hoodies at the Space Oddities shop. And again, you can scan the QR code, or you can click the link in the chat to go directly online to the shop. And we have a nice selection of hoodies and T-shirts for you there. And again, all the revenue goes towards keeping Space Oddities going. So we did celebrate our 3rd anniversary recently, and we'd like to go for a 4th and a 5th and a 6th and onwards. So with your help, we can do it. So thank you for anything you can spare. So without more ado, I think the first thing to do this evening is to go over to the news. So just let me sort that out, and we will go to this week's news. Give me 1 second just to get rid of our ugly mugs off the screen. Okay, So this is going to be the news for this week. Quite a few interesting things in the news this week. First thing is there's a possibility that an asteroid is going to hit the moon in the year 2032. Now, the asteroid in question is 2024 YR4. It used to be classed as a very dangerous asteroid for the Earth in the future, but it's had its orbit redefined, if you like, and it turns out it's not really a threat to the Earth, but it could hit the moon in 2032. The impact probability ranges between 3.8 and 4.3% at the moment. So, okay, it's not incredibly likely it will hit the moon, but it could do. And this animation here shows the possible points that the asteroid could encounter the moon. And although it's not a high probability, it might happen in 2032. We'll keep an eye on this one and let you know of any developments. And this is quite a large asteroid. It's about 400 meters across. So we'll just have to wait and see what happens with that one. Also this week, China has launched the Tianwen-2 space probe on a Long March rocket. It's heading to asteroid 469219. I know I'm going to butcher this. Apologies for any Japanese viewers. Kamo Oarewa. God, that's a terrible name. And it's heading to that asteroid on a sample return mission. And the asteroid in question is quite an elongated asteroid. It's classed as a near-Earth object. It's also classed as a quasi-satellite of the Earth because it orbits the sun in a way that makes it appear to follow the Earth in its orbit, although it doesn't really. But the spacecraft, the Tianwen-2 spacecraft, is on its way to take some samples and then send them back to the Earth. This asteroid is elongated and it rotates very fast, and it's about 40 to 100 meters across. And scientists think that it's actually part of the moon that was ejected during a major impact on the moon. They think it may have come from the big Giordano Bruno crater. And if the samples demonstrate that, that'll be really exciting, because it's the first time we've actually got a piece of the moon apart from the moon itself. So that will be quite interesting. It's going to rendezvous with the asteroid in 2026, study it for 7 months, take some samples, send the samples back to the Earth on a capsule that, as they've done before, drop through the atmosphere on a parachute to be recovered. But that's not the end of the spacecraft's mission, because then it gets reassigned to rendezvous with Comet 311P Pan-STARRS in 2032. And that is going to be an extended mission to go to a comet. So we've got some exciting stuff coming up over the next few years from that spacecraft. Moving on.
Andy, with an elongated object that's a fast rotator,
yeah,
that seems like a challenge to touch down on the surface.
I was thinking that myself. That's going to be really difficult to land on. But they think they can do it.
Right, and you're kind of gauging when the rope's going to come around, and you have to.
Yes, absolutely.
No, that's my best analogy. That's all I can do.
Yeah, well, good luck to the Chinese, because it does sound quite a daunting challenge to land on that fast rotating object. Now, this is an interesting one. NASA's Chandra X-ray telescope has seen this incredibly strong and powerful jet coming out of a black hole at the so-called cosmic noon. So this was only about 300 million years after the Big Bang, and it's called the cosmic noon because there was lots of black hole development going on there, and a lot of star formation. So that's an artist's impression on the left. The jet in question does show a sort of a spiral structure, which is interesting. The inset is from the Chandra X-ray telescope. You can see the black hole, or obviously the radiation around the black hole, the X-rays around the black hole very clearly, but you can clearly see the jet going off to the northeast. Now, what's so interesting about this, and Lou, you would love this one. This was only
Don't say
visible.
dark matter. I won't.
No, nothing to do with dark matter. It's to do with the CMB, because the only way that Chandra spotted this was that the radiation excited photons in the CMB and made them more intense. And it's I'll tell you all about it. So this is sorry, not 300 million years, 3 billion years after the Big Bang, dropped to zero there, and you can only detect it because its particles have boosted the photons in the cosmic microwave background to X-ray energies, and that's the only way it could be detected. And using this at the same time, they detected another equally distant black hole from about the same period, so 3 billion years after the Big Bang. They combined this data with data from the VLA, the Very Large Array, the big radio telescope array in New Mexico. And this allows astronomers to investigate how black holes shape their surroundings during this critical era that is referred to as cosmic noon. And that's it, really. And this was at a time when supermassive black holes were growing faster than at any other time during the history of the universe. And so spotting this jet from this really early black hole using the CMB, I think, is quite unique. I'm not sure it's ever been done in that way before. So that's quite exciting. We get to learn more about the history of black holes and the early universe. Lovely image this week from ALMA and the VLT in Chile. This is a protoplanetary disk around a star referred to as RIC 113. Now, what's interesting about this is that initially the observations were done with ALMA, and the VLT had a look at it. ALMA had spotted this disk structure, but with a dark band in it, which indicated perhaps the presence of a planet forming. And when the VLT had a look, it found something quite interesting. Now, the way that works is that they put the light from this star through a spectrometer called SPHERE at the Very Large Telescope in Chile. And what it found, as you can see from this image, that there's a sort of a spiral structure in the inner disk. And they've now detected the presence of not one, but 2 planets in this forming planetary system. And they're not quite sure what that spiral structure represents, or whether it's typical of early planetary formation. But they've discovered there were definitely 2 planets forming around that star. So that you're looking at an infant solar system there. I think it's a beautiful image. Next up, we have another discovery, something that's we've never seen before. An asteroid belt around a star that is about the same temperature and the same size and about the same age as the sun. But this asteroid belt is really different. So the star we're looking at is HD 69830. It's 41 light years away in the constellation of Puppis. And the NASA Spitzer Space Telescope spotted warm dust around the star. And when they had a look, it's commensurate with an asteroid belt that's larger and closer to its star than our own asteroid belt, but it's 25 times as massive, and it would fit inside the orbit of Venus. So it's about the same distance as the orbit of Venus from its star, but it's a truly massive asteroid belt with 25 times the mass of our own asteroid belt. So the very fact that we can now detect asteroid belts around other stars, it just shows you how far the technology is moving in, and the discoveries that we can make now and will make in the future, if, of course, Donald Trump doesn't cut the entire NASA space science budget. So there we are. And then this is one for you, Lou. Discovery that Titan's atmosphere wobbles like a gyroscope. So it's something very peculiar about this atmosphere. Rather than staying constantly fixed in line with its surface, the atmosphere wobbles across the course of the seasons like a gyroscope. And this was made in new research by a team from the University of Bristol in the UK. through 13 years of infrared light readings of Titan. And they've obviously inferred gas composition and temperature from those readings. And from there, the shifting position of the atmosphere. It's not clear what's causing that atmosphere to do that, but it could eventually lead to insights about the history of Titan and other planetary bodies that are like it. That includes the Earth, of course, because Titan has this thick atmosphere like the Earth. It has liquid lakes and it has weather patterns like the Earth. The seasonal shift of the wobble suggests the tilt might have something to do with the moon's yearly cycle around the sun in tandem with Saturn. A year on Titan lasts nearly 30 Earth years and comes with major changes in heating and temperature. Mm-hmm. So this is quite interesting stuff.
I think there is also I mean, we don't know. That's the best answer and that's the most correct answer. But there is some speculation that sometime in the distant past, perhaps a collision knocked the atmosphere off of its spin axis with the solid planet, and that produce this. But all of this has got to be taken into account in computer modeling. So I'm sure we haven't heard the last of this.
But the fact that it's seasonal indicates that there is some external factor in this as well. I would think.
Yeah, and Titan has a really weird atmospheric response to seasons. It's kind of like living in Los Angeles. You only have 2 seasons, right? Summer and winter.
Right. Yeah.
Well, for Titan, you can have wholesale movement of the atmosphere from one hemisphere to the other every half Titan year, so roughly every 15 years.
Wow.
That's because of its slow. That's the Hadley cell circulation. That's because of its slow rotation, and then 15 years or half a Titan year later, the whole atmosphere moves back. So that's a big movement of energy and momentum, and maybe that has something to do with it. I don't know.
Right. Thank you. I mean, it's an infinitely interesting place, isn't it?
Infinitely.
Yeah, and we will know more when Dragonfly gets there. So just have to wait a few years for that. Okay. Moving on. Europe has got a new asteroid hunter. It's called Fly Eye because the telescope is modeled on an insect's eye. So here we are. You can see here the first light from this telescope. You can see the black dot in the center. This is obviously looping. That's an asteroid spotted by this new asteroid hunter. And it's a new planetary defender for Europe. And this is actually asteroid 2001 KR1 you're looking at in the animation. And they've designed Fly Eye to be very, very wide angle like an insect's eye is. Covers an area more than 200 times larger than the full moon in a single exposure, much larger than a conventional telescope. And it will use this wide field of view to automatically survey the sky every night, cloud permitting, obviously, independent from human operation, and identify new asteroids that could pose a hazard to the Earth. And this is only the first Fly Eye telescope. They're hoping to build 4, 2 in the northern hemisphere and 2 in the southern hemisphere to give all sky coverage. And this is great that we have a new tool to spot these dangerous asteroids, because as we all know, sooner or later the Earth is going to get hit by an asteroid, as it has throughout history. So we need to know where they are and how big they are and what their orbits are and everything. So well done, Europe. We have another tool in the arsenal for asteroid detection. Lastly, the question of Milkdromeda. Now, what is Milkdromeda? This is the name that's been given to the eventual merger of the Milky Way galaxy, our own galaxy, and M31. scheduled to happen in between 4 and 5 billion years time, but a new study has thrown serious light on whether it will actually happen at all. Because what they've done, they've taken Hubble data for the last 10 years and done a really careful analysis of the movement of M31. And now they believe that it's only got a 50% chance of hitting the Milky Way galaxy. This is obviously an artist's impression of what we might see in the distant future, or whatever is on this Earth in terms of life, if there is any, might see in the distant future during this merger. But it now looks as there's only a 50% chance that the Milky Way is going to collide with the Andromeda galaxy. So a bit of a disappointment, really, but still 50% is better than nothing, I suppose. So there you are. So that's the news for this week, and some really interesting stuff there. Let me just come and rejoin.
Andy, while I wonder what that means. In the local group of, I don't know, something like 50 galaxies, the Milky Way is huge, and Andromeda is twice as big. These are the biggest, baddest galaxies in the group. And they are clearly coming toward, in some sense, each other. Maybe it won't be a head-on, and the word collision, of course, as you all know, is kind of not really what happens. But maybe they'll just pass each other by, in which case they will feel each other's gravity, and then you just have to do your endpoint models and see how long it will take for them to associate. I would like to know more about that. That's very interesting.
Yeah, there hasn't been. I mean, my first question was, well, 50% of what? So are they saying that if you say the 100% is 100% certainly that the collision will happen, so it's only half as likely to happen, but they haven't actually stated 50% of what, which is the obvious first question. But I thought that it had been established that the Milky Way and Andromeda are about the same size now.
I think by mass, I think Andromeda is about twice as massive.
Right. Perhaps in diameter, it's about the same size.
Perhaps.
Yeah, because when I was young, I learned that its diameter was much greater than the Milky Way. But I think in recent years they've done more studies, and they think they're about the same size now. But mass-wise, you're probably right that Andromeda has a lot more stars. So there we are. Interesting stuff. There are viewers. Hope you enjoyed that. Can I just pop into the chat here and say hello to a few people? Good evening, Mike. Good evening, Anne. Jerry. Oh, Daz is there. Daz is in a hotel. Hope you're having fun, Daz. Hope you're not sober. Hello, Ian. Daz again. Hi, Derek. Hi, Alan. Let's see who else is here. Sandra's. Is Sandra here? I thought I saw Sandra.
I think I saw her earlier.
I saw Sandra earlier. Gerard, thank you so much for your kind donation, sir. That is very kind of you. And I hope you're well. Hope you're recovering and look after yourself. And so there we are. So we've got some usual suspects in the chat. Thank you all for joining us very much. Okay, let's move on for this evening. And what we're going to do now, I think, if I remember rightly, is we're going to go over to Lou now. And hang on. No, we're not. Oh, God, I've got technical problems here. Let's go to Roger for the night sky.
Okay. Thank you very much.
I've got to follow Roger. That's a hard act to follow.
Follow that.
Oh, well. It's all downhill after me. There we go. Anyway. Okay, so we're proceeding on through the month of June, heading towards longest day, but that'll be another week's time. But there we go. So tonight we are having a full moon, and the Americans like to call the June full moon a strawberry moon. And there'll be some more interesting information about tonight's moon, because it's not only a full moon, but it's a standstill at the moment. And I'll go into that a bit later on. Spoiler alert. Okay, so we're still currently experiencing the galaxy season constellations of Leo and Virgo, and also Mars down in the western horizon. And we are now gradually getting to see more and more of the summer triangle. And obviously with that, we will also be getting the Milky Way core down through the southern horizons, down towards Scorpius, and all those lovely Messier objects coming up through from that. So things are looking quite nice. So we're just waiting for astronomical darkness to come back again in another month or so. So things will be a lot better then. But we still got quite a few planets coming up just before sunrise, and following on from the sun, we've still got Saturn and Venus in the morning, and then promptly following on, we've got Jupiter and Mercury. So we've got Uranus there as well, but obviously with the bright dawn skies, we're not going to see much apart from Venus really, and Saturn if you're lucky. So there we go. But things are getting quite interesting. Right, so we have got tonight the lunar standstill, which happens every 18.6 years. It will be rising, well, from my position, about 9:25 tonight, and will quickly set about 4:15 in the morning. Now, this will only get to a height of 11 degrees above the horizon, so it's going to be a very low full moon tonight. And the reason for that is because every 18.6 years we've got a, what we've managed to find out is a Saros cycle, which Edmund Halley had tried to designate, but the reasons for that was incorrect from his estimates. But it's rising at its most southerly point this evening and setting at its most westerly point tomorrow morning. So it should be interesting to get some photographs of the moon rising quite low over the adjacent landscape. So let's see if there's going to be any clear skies for people to get some interesting pictures of that event. So let's see who does that for the gallery. Hint, hint. Probably me.
By the way, when is the next lunar standstill?
Well, the previous one was 2006, and the next one is in 2043.
Oh, that's cutting it fine.
Yeah, well, good luck with that. Let's see if we're still able to present SpaceOddities at that time of life.
Who knows?
Who knows? Right, we have a little gallery, but there we go. First one is from me. One of my many lunar images that I've managed to get when the skies allow it. So
it's quite luminous, Roger. Very nice.
Mm-hmm.
Very nice.
So there we go. And we've got one from Lee with his S50. Have we got this one already? Yes.
Oh.
This is the Eagle Nebula.
Wow.
Where we've got right in the center the pillars of creation that Hubble brought to everyone's attention.
Wow.
How do you do that with a 2-inch telescope? That's just magic.
I know.
Isn't it? That's amazing.
There you are, Lou. Get on with it.
No, I'm going to start copying Hubble images too and putting them up and saying I took it with my S50. Nobody will be able to tell.
All right.
Whatever you do, Lou, don't take the bits from your sea star and put them in a bag somewhere.
Roger that.
Oh, well. Okay. Right. So we've got a few from Tom this week. This one is the Spider Nebula, part of the Spider and Fly Nebula in Auriga. And they've got 18 hours of exposure with his 8-inch Skywatcher with 5-minute exposures. And this is what he's produced.
18 hours.
Yeah. Those little star spikes are a giveaway for a Newtonian, though.
Mm-hmm.
I think we might be a bit more suspicious if it was 6 spikes, because that would be from the James Webb.
Aha! Hey, don't give away our secrets. We know how
Okay.
to do that.
But fantastic. Lovely details
Beautiful.
there. Mm-hmm. And then we've got the Bodes Galaxy, which he's only managed 13 hours of with his usual gear, but this is with a one-shot color or one-shoot color setup, as he's put it here.
Whoa!
And we've got some great detail there in the central lanes there, and the spiral arms as well.
In color. I mean, look at the.
Wow.
Wow, look at that.
That's what happens when you spend 13 hours on it.
That's amazing.
It's lovely. He does a good job, that man.
He does.
And then we've got the Medusa Nebula. Now, I've not been aware of this one, but he's spent 14 hours on this one. And he says it's a magnitude 16 planetary nebula.
It's pretty dim.
Wow.
Wow. I don't think I've ever seen that before.
No, I don't think I have either.
This is my first time of knowing this. So
yeah, I can only see down to magnitude 15, but I mean, this is 60.
Oh well, you'll need the new C Star S70 then, Lou.
Oh, keep wishing. That's a rumor. We have no confirmation.
Okay. And to finish off Tom's contributions, we've got the Aurora from last October. And this was from his back garden on his mobile phone.
Wow.
Wow. Amazing.
Imagine if you didn't know what that was. You'd think the atmosphere was on fire or something.
Absolutely.
Yeah, absolutely.
Yep. Okay.
Yeah, Matthew, we'll come to Matthew in a moment when we talk about Jupiter.
Okay. And to finish off, I took some images of the sun today, and this was what was visible.
Oh, man.
Wow.
Your images of the sun are always so great.
This is an inverted image this time with the white spots rather than the black spots. I couldn't do any more because it was so cloudy. There was only very small breaks to capture this, and this is what I managed to get. So
that's wonderful.
It's okay. It's good.
It's comforting just to know it's still there. I mean, that's enough.
Yeah. So there's a couple of the active regions down the bottom there, 4105 and 4107. So there we go. And that's what we have for this week's gallery and what's in the night sky.
Thank you so much, Roger. That's absolutely brilliant. So thank you, as always. Well, there you are. And if you would like to send your images into the gallery, of course, as ever, attach them to an email and send them to info@spaceoddities.space. No, don't do that. Send them to gallery@spaceoddities.space. We'll find them anyway. And if you could just restrict yourself to one image per email, please give us all the details. And of course, your images will appear in your own little gallery on the Space Oddities website. And if you want to visit the Space Oddities website, then you're more than welcome to do so. And I'll just put the address up on the screen for you here. We are https://spaceoddities.space, where you will find the aforementioned galleries of everybody who sends images into our weekly gallery. They have their own little gallery on the website, and have a look at the website because there's stuff about us and lots of other stuff there as well. So we hope you'll pay that a visit at some point. So what we're going to do now is we're going to move over to Lou for tonight's star billing. And Lou's going to be telling us about the 2 spacecraft that are currently on their way to the Jovian system to study the moons of Jupiter. And let me just put up what Matthew said before I forget. And Matthew said JUICE will be doing a flyby of Venus by the end of August 2025. So we've got hopefully some great images of Venus to come from JUICE. What is JUICE? JUICE is the European Jupiter Icy Moons Explorer, which, well, I will let Lou tell you about both spacecraft. But what we're going to do is put the, yes, Gerard, do get well soon. And we hope you're able to join us more full time when you're better, which of course you will be. So take care of yourself.
Yep.
Get lots of
Get
rest.
better.
Yeah, get better soon. And yes, so Lou is going to be doing a battle of the Jupiter explorers, basically, or the Jupiter bots, and we'll just get that up now. And I'll hand over to Lou to tell you what it's all about.
Okay, thanks, Andy. Hey, first I want to say how grateful I am to Roger and our viewers for showing us what's in the night sky. I don't think we've had a clear night here in 3 weeks.
Oh.
And every night I go to the sliding glass door and I open. It's either raining or it's cloudy or it's too hazy. But so thanks for letting me know that it's still there, and I still have hope. Okay, that said, today we are going to do the battle of the spots. In the left corner, we have the Europa Clipper on its way to, well, Europa. And on the right, we have Jupiter Icy Moons Explorer on its way to, well, mostly everything else. Who will win? Who will win this bout? And I'm going to need the help of our viewers. We'll look at each spacecraft. We'll look at the moons that they're exploring. We'll evaluate them every way we can. And at the end, I need you guys to vote. Who will win, Europa Clipper or your Jupiter Icy Moons Explorer?
There we are.
Let's get on with it. All right, well, let's put things in perspective. We're going out 5 AU from the sun, 5 times further from the sun than the Earth is. So you use your 1/r² law, you get 1/25 as much light per square area. And so we are now officially in the cold, icy outer solar system. And because it's icy, because it's a cold solar system, and because water is ubiquitous through the universe, as we now know, the moons that we'll be talking about today are called icy moons. They have a fair amount of water, and I'll be able to demonstrate that in a few moments. But these are moons of Jupiter. These are Galilean moons, some of the largest moons of Jupiter. They orbit at different orbital periods and distances, and we'll see how that has an effect on their physical properties. They're orbiting the largest planet in the solar system, Jupiter, which is a gas giant, and which rotates extremely fast. This is, by the way, Roger knows this, that you can't do an exposure on Jupiter for more than about a minute and a half or so, because it will have rotated, even as large as it is, too much, so your image starts to get blurry. Jupiter now has 95 moons, and I remember when I was giving a talk on the solar system in 3rd grade, as I was telling Andy earlier today, it had 12 identified moons. We've built bigger telescopes, sent spacecraft, better detectors. So we're going to talk about a few of those moons today. Okay. One thing that Jupiter has that turns out to be very important is a massive magnetic field. It is the biggest thing, except for the heliosphere. It is the biggest thing in the solar system, bar none. The Jovian magnetic field is swept backward, just like our magnetosphere is, by the solar wind, and goes all the way to the orbit of Saturn. That's 5 AU. This thing is massive and it's powerful. So we already know we're dealing with a really high particle radiation environment. And that means that you have to, if you're going to the Jovian system, you have to design your spacecraft so they are really radiation hardened. And the closer you get to Jupiter, the more radiation hardened you have to make your electronics, or it's goodbye spacecraft. So here we see Jupiter with its plasma torus, a good part of that contributed by Io from its volcanism that spews material into space that follows magnetic field lines into the atmosphere of Jupiter, and by the way, causes aurora in the northern and southern hemispheres. So in order from Jupiter, moving outward, it's Io, Europa, Ganymede, and Callisto. And it turns out that the distances of these moons from Jupiter plays a large role in their physical attributes. Out here, where there's very little sunlight, there is some sunlight, but there's very little sunlight. You have to rely to a large extent on other energy sources, right? So one energy source is the positive heat balance that Jupiter has. Jupiter is actually generating more heat, more heat than it absorbs as energy from the sun. And the other is Jupiter's gravity field that causes tidal friction. And the other is Jupiter's magnetic field. So you're dealing in a different regime in a lot of ways than you are here on Earth. So you better account for that in the missions you send. Okay. So here they are with relative sizes, again, moving out from Jupiter, Io, Europa, Ganymede, and Callisto. Not quite as much for Io, but the other three moons, it is suspected that they have subsurface oceans. Io too, but I think to a less extent. And certainly Europa is the focus of a subsurface ocean with more water, more saline water than all of the oceans of the Earth combined. So since we know that everywhere on Earth we find water, liquid water, we find life, water is what we go out into the universe to look for.
That's quite a thought, isn't it, Lou? That little moon, and Europa's not a big moon.
It's the smallest of the four, yeah.
Yeah, it contains more water than all of Earth's oceans put together. I can never get over that fact. That's incredible.
I think one thing that we're learning is that not just the solar system, certainly the solar system, but in the universe, water is ubiquitous, right? It's everywhere. Lots of hydrogen, lots of oxygen. They love each other. They want to come together, and there's just a lot of water out there. As you say, Europa is not that large. It's the only one of the three that is smaller than our moon, just slightly smaller than our moon. The other three are larger than our moon. And by all accounts, if they were orbiting the sun, they might very well be major planets. So they're different. Io is very volcanic. Europa has an ocean very close to it, relatively close to its surface. Ganymede has an ocean, a liquid water ocean as well, further below the surface, and apparently Callisto as well. And a good deal of the energy for keeping that ice, which would otherwise be ice liquid, comes from the tidal heating from the slight eccentricities of the orbits of these moons as Jupiter tugs first one way and then another on these moons. Okay. So let's look at a few of the extras on these beautiful automobiles. So it's from Ralph Spoilsport. What do I want you to see? Let's look at the density of these moons, okay? 3.5, 3, 1.9, 1.8. Earth's bulk density is about 5.5. These are grams per cubic centimeter. And so as you move down from there, and that's very typical for the inner planets, Mercury, Venus, Earth, Mars. But as you move down from there, you're looking at bodies that have more and more and more water and water ice. So that's why we call these icy moons. Okay. If you look way over to the right for eccentricity, not huge, but they do have some eccentricity in their orbits. And that means that the gravity felt by Jupiter will be felt at different intensities throughout the moon's orbit. And so this is producing enough heat to generate, to keep the liquid water inside these moons, liquid. So, so I think that's about it for there. So density, there's a lot of water. Eccentricity, there's a lot of tidal heat. So that's the system we're looking at. Let's see what we're going to do about it. Well, the first is Europa Clipper. It has been launched back in October of 24. It will arrive at Jupiter in 2030. All of these missions have multiple gravity assists. Its primary, and in fact, to a large extent, its only target is Europa, because of the extreme interest in Europa as possibly harboring life. It will orbit the Jovian system for 4 years. Now, it is not orbiting Europa, as I had once thought. I'm not sure why that's the case, but it is orbiting Jupiter and will make 49 flybys of Europa. And it's a NASA mission. Okay. Our contender is JUICE, Jupiter Icy Moons Explorer. It also has been launched back in April of 23. It will reach Jupiter in July of 31. Now you notice it was launched earlier and it will arrive later. This is simply a product of the geometry of the solar system, where various planets are in their orbits and how you have to construct the multiple gravity assists that it takes to keep these missions affordable. JUICE has a primary target of Ganymede. Again, a moon with, although buried a little deeper, we suspect a global ocean underneath the ice sheath. But it will also be looking at Europa and Callisto in flybys. I guess I should mention here, one thing we didn't talk about, Ganymede actually has its own global magnetic field. We saw this with Voyager. We saw this with Galileo. The other three, Io, Europa, Callisto, do not have their own magnetic fields, but they have induced fields. And these induced fields come from interactions with the Jovian magnetic field, which produces movement of charge through these oceans, which generates its own magnetic field. And so we can see the magnetometers on these missions tweak as they go by these other three moons, indicating that they don't have their own magnetospheres, but that they are induced. Duration of mission. Once they get into orbit, once they have orbit insertion, Europa Clipper will be orbiting the Jupiter system for 4 years with 49 Europa flybys. And JUICE will be orbiting for 3.5 years. And at that point, it will go into orbit around Ganymede. And it will stay in orbit around Ganymede. I'm sorry, I don't remember how long that is. But eventually, they will crash it into Ganymede, so as not to have an unpredictable orbit that might obscure or crash into some of the other moons. And again, Europa Clipper is primarily a NASA mission. JUICE is an ESA mission with NASA and JAXA participation. And I'm pretty sure that some of the instrument teams on the NASA Europa Clipper come from other countries as well. It's very common to have international participation in these missions. Well, let's see some pretty animations. This is an animation from the Europa Clipper mission showing Europa as it's passing in front of Jupiter. And there's the mission.
That's a lovely animation.
Thank you, NASA Visualization Studio.
Indeed. They never fail.
Okay. And this is from from ESA for the JUICE mission, giving you a sense of what it would look like in deep space. Okay. All right, let's dig into this. I've been nice so far. We haven't talked about this in any depth, but you got to get into it pretty deeply if you're going to pick a winner. So let's do this. The Europa Clipper is going to determine if Europa is habitable. And I think by that it means what are the variables in the subsurface ocean, enough heat, enough organics, this kind of thing, a method of getting nutrients into the ocean. It is not looking for life. It is looking for habitability. The JUICE mission is going to study the habitability and the evolution, a little broader spectrum of Jupiter's icy moons, Ganymede, Io, and Callisto. Europa Clipper will be measuring the thickness of the ice sheath on Europa. It will have spectrometers to identify composition, and it will be looking for plumes, subsurface ocean plumes that will indicate heat and nutrient possibilities. JUICE will be exploring Ganymede's subsurface ocean as well, and its ice shell, again, much thicker than the Europa shell. And from that and other measurements, we'll be making some deductions about its internal structure. Europa Clipper will investigate the induced magnetic field that Europa has, and we know this. This is one of the reasons that we came to the conclusion, planetary scientists came to the conclusion that Europa has a saline ocean, because saline oceans conduct electricity. And as we know from Michael Faraday in the 1800s, moving charge, electric current, generates a magnetic field, and that's what we sense with our magnetometers when we fly by the moon. The JUICE mission will be studying Ganymede's intrinsic magnetic field, and that, again, is unique among the moons of Jupiter, and I think among all moons of the solar system. In terms of habitability, Europa Clipper is really going to focus in on this. Europa jumped right to the top. Europa Clipper jumped right to the top of the planetary decadal survey as something important to do because of its potential for a saline ocean and potential for life. And it seems to me that any wise planetary scientist who wants to study their body and send a mission to it just has to come up with a theory that it has a subsurface ocean, and boom, you're going to get funding. Okay. It will look for biosignatures spectroscopically and other habitability indicators, but again, it is not looking for life. I might have told this story, but I have a good friend at Goddard who is a planetary scientist who believes we should be looking for whale bones on Europa. And the idea is that it's a moderately thin, few kilometers, I guess, crust. You get a big enough impactor, it slams in, goes down to the ocean below, and there's this big spray, right? Just like dropping a big rock into the lake. And that spray is going to bring up whatever is in the ocean. Well, maybe if there are fish, if there are whales, they will land on the surface, and eventually we will find whale bones on Europa. So we will see. We will see.
Wow, that's a thought, isn't it?
Well, that's an interesting idea, thinking out of the box.
Yeah.
For JUICE, it is looking for habitability, but it is also focused on general physical attributes, the geology and the atmosphere. And there'll be the JUICE team and other scientists will be building models of the atmosphere and its evolution. And when I say atmosphere, I'm talking really thin, okay, not like the Earth's atmosphere. Beyond that, Europa Clipper's correctly named. It is going to focus on Europa. And JUICE has a little bit broader menu of opportunities. Well, how about the mission design? How about the instruments that are carried on these spacecraft? Europa Clipper will be an elliptical orbit. I said 49 Europa flybys. This says 50. I'll have to verify that. The JUICE mission will orbit with an eventual Ganymede, orbit the Jovian system with an eventual Ganymede orbit. Each one has on the order of 10 instruments, ice penetrating radars for Europa Clipper, thermal imagers, which will look in the infrared for heat sources and also for composition, and mass spectrometers, which can sample the rarefied atmosphere and as well as any material from plumes. JUICE has 10 plus instruments. It has a radar for doing topography, an altimeter, a magnetometer, of course, measuring the magnetic environment, and both ultraviolet and infrared spectrometers. Okay. They're both heavily radiation shielded, but Europa much more so, because Europa is a lot closer to Jupiter, and Jupiter's denser part of Jupiter's magnetic field than our Ganymede, and so Europa Clipper will be in a higher radiation environment. Let's see, water plumes can be detected for Europa Clipper. JUICE doesn't really care. And they're both solar powered, which is, I think, that's a cheap way to go. It is surprising that you can power, I think, a spacecraft that from solar power that far out, but we've done it before. All right, various strengths. Europa Clipper, best for focusing on Europa and habitability. JUICE, few Europa flybys. Ganymede science, flybys only for Europa Clipper. Deep investigation for JUICE. Habitability, that's why we're sending Europa Clipper, and it will be doing spectroscopic detection of biosignatures, molecules that are prebiotic. JUICE is, yes, some of that, but more on physical attributes of formation and evolution, a little bit less than habitability. Both are radiation tolerant at the levels they need to be, a little bit more shielding for Europa Clipper, and we've already identified their targets. So, which one is better? Well, here's some things you might want to think about. If you're searching for habitability of life, Europa Clipper, that's in its mission design. It's really designed for that. If you are looking for a broader understanding of the Jovian system, JUICE. It has a much broader set of targets and investigations. Technologically, they're both extremely advanced, highly radiation tolerant, and I'm sure they will both outlive their planned mission timelines, which will make them prime candidates, especially if you're going all the way out to Jupiter. That will make them prime candidates for extended missions, assuming we still have space programs at that time. So here's a graphic that might help you compare. This just says more or less what we just said in words. Focus on Europa, focus on Ganymede, habitability, the overall, the Jovian system science, radiation tolerance, and technology innovation. They are tied. So, my friends, what is your vote? What do you think? Europa Clipper or Jupiter Icy Moons Explorer? You decide.
Well, I think another way of putting this question might be, which spacecraft's results are you looking forward most to seeing? I think that's just basically the same thing, isn't it? Because as you said, you know, they are looking at different things, so it's not a totally fair, if you like, comparison. So tell us, viewers, in the chat, whose spacecraft results you're looking forward more to seeing. You know, as Lou said, that they're undoubtedly both very advanced, state-of-the-art spacecraft. And Daz has said, both excellent missions. Europa, a bit of a one-trick pony, and Juice covering more moons. I call it a draw. So there we are.
Well, you're no fun.
Yeah,
I want a winner. I want a KO in the ninth.
But Daz says, Derek says, I agree. So that's 2 votes for a draw. Any other thoughts out there? So put them in the chat now. Either way, we are extremely blessed to have 2 spacecraft on their way to the Jovian system. And, you know, we should think ourselves lucky that we've got any, really. So it will be interesting to compare the results.
That's an excellent point. They will be orbiting Jupiter at the same time. And I'm sure that there will be correlative science going on like crazy and sharing of results. That's what the scientific community does. They share.
Right. Okay, so Paul says, Sandra says Europa for me, looking for life and habitability.
There's a vote.
Yeah, and Paul says it's so close, but for me, Clipper's biosignatures detection is so exciting, and Juice's lack of plume detection seems a mistake. So that's another vote for Clipper. Any others? Any others want to express a preference?
I'll be sending this, by the way, to the administrators of both NASA and ESA with your names on it. So just feel free to speak to them.
You think he's joking. So nobody else want to express a preference?
How about you guys?
Yeah. So, Roger, what about you? What do you think?
Well, I think the Europa Clipper will be getting quite a lot of information, but obviously with both of them working and roughly at the same time in the same sort of areas, we will get a lot of interesting results. And obviously with both of them working maybe together, they'll be able to correlate each other's information to see if there's any differences in the measurements that they're both picking up from the area that they're currently exploring. So it'll be interesting to see how close the results are when they both get to do their studies.
Yeah. I think what I'm most looking forward to is the joint study of Europa's ice, because that will be very, very interesting. And you know, one hopefully will verify the other. So Sandra says they're both exciting missions. They are. Well done. And so we should look forward to 2030 and 2031. It's not far away now, 5 and 6 years away. I'm sure that time will pass quickly. And we'd like to thank Lou for telling us all about those 2 amazing missions.
Just one more thought.
Yeah.
We're kind of leaving out an important element of this, and that is the press.
Right.
And I imagine that the press is going to go nuts over any suggestion that there might have been at one point the possibility of perhaps the existence of prebiotic life on or in Europa, you know, that kind of thing. And you'll see you know, astronomers found life on Europa in all of the headlines. So just wait.
Yeah, absolutely. And yes, they will go mad. And you can just see the headlines now. Life found on Europa. You know, when they haven't found life on Europa. So,
Mhm.
but another interesting thing I meant to ask you was what about the price? What about the cost of these missions? Are they comparable in cost? Do you know?
That's a good point. I'm not sure, but I believe that the JUICE mission, the cost has been shared between few governments, and
Right.
not as
Yes.
clear
Well,
on
yeah.
Europa Clipper, so
Yeah.
that will make a difference.
Yeah, and being part of the European Space Agency, of course, there will be, all of Europe contributing towards it as part of the ESA budget for the whole of Europe. And Daz says, I think Wales will hit the headlines.
Oh, you just wait. I bet.
Yeah.
You know how on Mars we saw the face on Mars,
Yes.
right?
Yeah.
And we're still seeing caves on Mars, and you name it, from orbit, and I guess from rover. So we will see those kinds of things on
Yeah.
Callisto.
So Stuart says another vote for Clipper from Stuart. So it looks like Clipper's pretty much won. So
I think it's pretty clear. We need to cancel JUICE and move that money over to Europa Clipper, maybe.
Yeah. I think at the end of the day, we all know NASA's excellence in planetary science, and I'm going to stick my neck out. I think on every single NASA planetary mission, we've always discovered things that we didn't know existed or didn't suspect existed. So we can expect, I think, not just data from the Jovian moons, but surprises, big surprises. So expect the unexpected.
Every mission. And listen, do not sell. Oh my goodness, do not sell ESA and their planetary exploration program short. They have made major contributions to our understanding of the formation evolution of the solar system, and will continue to. So,
yes,
the jury's out.
There was actually an American on Facebook last week saying, why do you pay for the ESA? The ESA has never achieved anything in space.
Oh,
and
my goodness, how short-sighted.
Well, of course, I gave him a complete list of ESA's achievements in space, including, of course, which we're very proud of in Europe, the first spacecraft to visit the nucleus of a comet with Halley, first spacecraft to orbit a comet, first spacecraft to land on a comet. 2 spacecraft landed on Comet 67P, of course, the little Philae rover, and then the spacecraft itself. So Europe has a great tradition of planetary and cometary science, and I'm sure that both of these missions, Europa Clipper and JUICE, are going to be major successes for their respective senders, if you like. So there. So anyway, Alan says, can't wait for a whale steak. I'm with you, Alan, definitely.
Heavily irradiated, yes.
Yes, probably heavily irradiated in the case of Europa, definitely. But I mean, it would be wonderful, wouldn't it, if either JUICE or Clipper could spot something laying there on the ground that looked biological.
Clipper has a mass spectrometer. I wonder if you're, I mean, this very, very, very rarefied, if you will, atmosphere. Yeah. I wonder if you can detect the presence of barbecued steak.
Yeah, Paul raises a good point. He said, with both probes active in the same area, has anyone checked that they won't collide? It's a big
that would be the story.
Yeah. Oh God, can you imagine what the media would do with that? Oh dear, shudder to think. Yeah, good point, Paul. But it's a big space out there. I don't think there's any risk of them colliding. So there we are. All right. Well, listen, thank you so much for that, Lou. Very thought-provoking stuff. Can't wait for the results. And thank you. That was a great presentation. What we're going to do now, viewers, is have a look at a video because, as you know, a few weeks ago, we celebrated rather proudly our 3rd anniversary here at SpaceOddities. And Kareem Jaffa, who hasn't been seen on SpaceOddities for quite a while because his university teaching commitments do not permit him to join us on a Tuesday. But nonetheless, he's a fully fledged Space Oddity. And he sent us a video for our 3rd anniversary. And as I said, apologies we didn't share this at the time, but had technical problems with it that I've now resolved. So here's Kareem Jaffa telling you all about his contribution on the theme of the number 3.
Greetings everyone in Space Oddities land. It's Kareem Jaffer coming to you from Montreal, Canada. Sunny Montreal for once. I'm the public events coordinator here at the RASC Montreal Centre and the National Education and Public Outreach Committee chair for the Royal Astronomical Society of Canada. And I'm so happy to be celebrating 3 years of Space Oddities live. I have not been able to be on much the last year or so. My teaching schedule unfortunately conflicts with the show. But I thought today I didn't want to miss out on the chance to first off say thank you to you, our viewing audience, for continuing to watch our content and give us feedback and join us for this wonderful journey through all things space. And Andy for steering the ship, Daz, Michael, Lou, all of our contributors, Rachel, Roger with the amazing galleries, Tom, our newer contributors, Ian, Mary, and Susan, our older contributors who haven't been able to be with us for a while now. It has been a wonderful journey, and to celebrate 3 years, we're doing a theme of 3, so I thought I'd talk about 3 triangles in the sky. So first off, a quick land and sky acknowledgement as we always do. We are on unceded Indigenous lands, and I always like talking about the moons of the season. So we are in May and going into June, and we just had a new moon yesterday. So I don't have any moon pictures from this morning or last night to share with you, but I did want to mention that we went from the flower moon to the strawberry moon, as the settlers say, but it's interesting sometimes to see the knowledge that's in the indigenous names for these moons. So right now, if we look out in the farmlands here in North America, we have crops that are still very, very young and very, very green. And this is captured in the names given by, for example, the Mohawks calling it the Fruits Are Small Moon, or the Cherokees referring to it as the Green Corn Moon, because most of the crops that we want to be able to sustain our tribes or our villages, or these days our cities and our families through the years, we need to wait a little bit before we pick them. Otherwise, we're going to lose out on most of the actual ripe crops that will feed us and sustain us, and that are more flavorful, of course. So we'll start off with the most prominent one that we finished with during the head of winter, the winter triangle. And the winter triangle is in some ways kind of subsided by the winter hexagon, which a lot of us in North America will use instead. But the winter triangle basically goes from Betelgeuse to Procyon to Sirius, and it's the 3 incredibly bright stars, especially in the later winter time, very clear above the horizon to the south in the evenings. And they allow us to spot not just the stars that we want to spend time looking at over the span of this wonderful season, but also some of the stories from the indigenous cultures. And specifically, if you look at the Egyptian culture, Sirius was considered to be the most important star because the location of Sirius led to an understanding of when the Nile would rise. And Sirius and Betelgeuse were considered to be basically husband and wife, or wife and husband, actually, the wife being the more prominent. And Procyon was the 3rd in the triangle that was separated from the other 2 by part of the arm of the Milky Way that we would see, or the wonderful nebulosity and clusters of dark stars that we would see through the sky. Now, we could also talk about the 3 stars on the belt of Orion, but I'm sticking with triangles here today. So the spring triangle, which we are seeing just now when you go out at night in the evening times, especially here in the Northern Hemisphere, Arcturus, Spica, and Nebulosa are incredibly bright and visible. And I always enjoy using Nebulosa to see Leo because there's so many amazing galaxies to look for in the constellation Leo. And that's really what these asterisms are for. They are for not just connecting the constellations that enable us to kind of map out the whole sky, but also for locating the treasures of the night sky. So to be able to plan ahead for those treasures, let's look at the next season. And we have the summer triangle coming up. And the summer triangle remains prominent into the fall as well, which is why I'm sticking with just 3 triangles. And you've got Vega from the constellation Lyra, you've got Deneb from the swan or the whale Cygnus, and then you've got Altair, which is part of Aquila. And I love using Altair and Vega to look for Alberio, the double star, which bright blue, bright yellow, and that revolves in a 7-year cycle. So over the last 7 years, I've gotten to see them change position 1 full cycle, which has been a lot of fun to see. But I also enjoy, because the line from Altair to Vega, where it crosses through the bottom part of the constellation Lyra, is where we find the Ring Nebula. And the Ring Nebula is a planetary nebula that's very similar in terms of its origin star to what we think we will get as a planetary nebula when our sun dies in 4.5, 5 billion years. Depending, I'm going to give it that little margin of error. But that Ring Nebula, with both the color visible to your eye, a little bit of blue, a little bit of red, and with some astrophotography, you can pull out that white dwarf in the center. It allows us to talk about the death of our sun, which is one of the topics, the stages of the life cycle of a star, which one of my collaborators and colleagues here in SpaceOddities is going to talk about today. And then you've also got the beautiful globular cluster right next to the summer triangle in Hercules M13. And so I always use the positions of Altair and Vega in order to orient myself to be able to say goodnight every night through the summer when it's clear, which is not often in Montreal, to say goodnight to M13 and to the Ring Nebula, even from my driveway. So I encourage you all to find yourselves a planisphere or to get yourself a star finder. And if you're in Canada, come to one of our RASC Center events, the center closest to you, and get yourself a star finder, which is tuned to the 45-degree field of view, or the 45-degree latitude that we're at here in most of the populated areas of Canada. But there are online generators as well. If you're going to use a phone app, be careful not to ruin your night vision. And with that, I bid you adieu. Happy 3rd anniversary to all of my SpaceOddities live friends and collaborators. And we will see you all soon. Enjoy the night sky. And remember, you're not the first and you won't be the last to enjoy these treasures of the night sky.
There we are. So thank you very much, Kareem.
Much nice to see Kareem again.
Yes, absolutely. Yes, it'd be lovely, but as I said, Kareem's teacher commitments don't allow him to join us, but he's with us in spirit, if not in person. Let's hope we can get him back soon. Perhaps in the next academic year, he'll be able to join us. So interesting, 3 triangles in the sky and some very interesting objects there, which I'm sure you're all quite familiar with. Just before we go any further, Kenneth says he just got his M27 data from Siding Springs. Looks awesome. So excited to process these now. They might be on next week's gallery. Fantastic, Kenneth. Look forward
Certainly hope so.
Yeah, absolutely. And we will look forward to those, Kareem. Yes, do Kenneth, send them into the gallery whenever you can, because we'd like to see them. And we always love seeing your images. Okay, we're going to move on now to something that you've requested that we do, which is a bit more astrophotography. So I'm going to hand over to Roger now to show us all about this. So what's this all about then, Roger?
Well, I'm hoping that the presentation won't be too boring for people to understand, telling them how to suck eggs and whatever. But for those people that are not aware of how the process is, I'll give you some background details on what we can do to achieve some of the images that our regular members post in the gallery. So, right, okay, so. Right, so we obviously need the telescope on its mount, a camera to be able to take the pictures, whether it's a dedicated astronomical camera, a DSLR or a mirrorless camera. And then if we are using an astronomical camera, we need to be able to save the images to a computer, whether it's a desktop or a laptop. This is one of my setups that I currently have. So we'll go through the breakdown of what we have. We've got a 5-inch refractor here on top of the equatorial mount. Above that is another telescope. I don't usually have this set up exactly like this, but it gives you an idea of how we can achieve multiple captures at the same time if you want to. And obviously the little guide scope at the top there, which will help to alleviate any errors in the tracking of the object that we're currently trying to photograph. So we've got a little camera on the guide scope there, either that one or the one on the top, which will get a general wide field view of the sky of the object that we're currently photographing. And down at the bottom there, we've got the main camera, which will capture all those images that we will later process. This is a view of the camera. It's a fairly simplistic camera. It's basically just a sensor, something similar to what you've got in your camera. And you can see the sensor there in the center there. And this is an uncooled camera. You can have them cooled or uncooled, depending on what you're currently wanting to use it for. This is a basic uncooled color camera. It's a very small sensor. It's 8.8 by 13.2 millimeters in size, but it's 20 megapixels in total. So fairly good resolution, although the size of the sensor will give you a tighter crop in the field of view for the telescope that you're currently using. So if you wanted a wider field view, you either use a shorter focal length telescope or a larger sensor, or a combination. So with the color sensor, we've got what we call a Bayer matrix, which is made up of red, green, and blue filters over the actual camera sensor. And this is the pattern that you usually get over the whole of the sensor. So currently, if anything you're photographing in red will only use 25% of the sensor, as is the blue, but 50% of the color will be in the green part. So if you're a really dedicated professional photographer for astro imaging, then you use a mono camera and then just use the whole of the sensor with the appropriate red, green or blue filter over the whole thing, which will give you a much better definition and a sharper image. But to start things off, if you want to just do some general astro landscapes, here's one down on the south coast of the Milky Way. And no, that's not lava on the beach. That's just the sodium lighting from a car park on the joining car. Yeah,
it does look like lava.
I know. So it's just a combination of trying to get the camera exposure right, and just to make sure that it doesn't move, you've got what they call a 500 rule for a full frame camera, and a 300 rule for a smaller APS-C size sensor. So what basically you do is divide the 500 by the millimeters in focal length of the lens that you've got on the camera. So if you've got a 50 millimeter lens, you can have a maximum of 10 seconds exposure, or therefore if you go to a 25 millimeter lens, you can go for 20 seconds exposure before any star trailing occurs on the exposure of the camera. So just bear that in mind. So you obviously, if it's a bit dark, just adjust the ISO up to get a decent exposure and then just process it as you would in Photoshop. And of course, it can be quite interesting to find some foreground interest. This is at Portland Lighthouse down on the south coast in Dorset. And just to the right of the lighthouse is the constellation of Ursa Major.
Oh, yeah.
And over on the right, just towards the horizon, is Venus, and then we've got a crescent moon there, just about to set. So things can be quite interesting. And it's just an interesting position of just pointing the camera straight up and getting the lighthouse beams to radiate around and capture some of the night sky as well. And I believe that bright star about the 10 o'clock position is the star Vega. And you can just about make out this constellation of Lyra there as well. So it's all fairly straightforward. And here we are again, just taking a picture of the Milky Way. And that building there is just lit up by the moon, which is getting quite low down, but it helped to illuminate that building quite nicely. And if you want to do star trails, this is at the same location, just keep your camera fixed and just continuously take photographs until you've got quite a long length of exposures. Obviously, the longer that you actually take the pictures, the longer the star trails will be. But we've got a few interlopers here, and those were Chinook helicopters from a local army base flying about during night maneuvers to give you the interesting effects of those red lights. But you can also get meteors coming through and other aircraft, so it can prove quite interesting. And obviously you can do some quite interesting ones with reflections. And in the reflection of this one near the bottom is the planet Jupiter, shining quite nicely in there, which does enhance things quite nicely. And if you point your camera away from the pole, you will obviously get the trails falling away either to the right or to the left, depending if you're pointing it east or west. But as you might see amongst the star trails, I have managed to capture a few meteors there as well, little brief streaks there as well. So it can be quite fortuitous if you do this during a meteor shower as well. But most of my equipment that I do my solar and lunar imaging is just using a basic SkyGuider Pro tracker. This is what we've got here. This one's made by Ioptron. Skywatcher also do one as well. So you can set this up to use it for doing through the normal with a little telescope, or you can just use a little camera with a telephoto lens, and it will give various tracking rates depending on what you want to do, whether it's for the moon, the sun, or for general using of the night sky. And if you want to do it with some landscapes, it will do a half rate as well, or just switch it off and just let it rotate round. So here's a couple of pictures where the telescope, the mount is actually pointing towards the North Pole, thereabouts. And using a ball and socket head, you can obviously rotate the camera around to any position in the night sky, and it will then be able to track that to enable you to get perfectly good tracked stars with no trails and lots of deep sky objects like we've been seeing from Tom earlier this evening. But if you want to do star trails like this, just try to point it somewhere towards the center. If you notice on this image on the right, you'll notice that the pole star is practically right in the middle, so it only turns around very slightly. So wide aperture, wider the better, a reasonable size ISO as well, so we can get those images captured quite nicely. So this is a time lapse as you can see, the star is slowly rotating round. And when you finish processing the images into some of the software that I will mention, you will get these star trails. And obviously, the longer the star trails, the more of the circular images that you will get. And you may also notice that the star colors will come out quite well on this. And this is obviously just showing you how the rotation of the Earth moves in relation to a static tripod. So once you start seeing some of these, you might notice things shooting across the sky, usually some aircraft, but generally a lot of satellites, unfortunately. And things aren't getting any better when Elon Musk with all his tracking satellites. Now, this is what would happen if you've got your telescope or camera set up with the camera permanently focused on one spot in the night sky when you've got it all polar aligned. And you'll notice that the stars stay in perfect position, allowing you to take picture after picture to stack all your images into wonderful creations that we get from the gallery viewers.
Fantastic.
And as you see, those darn satellites spread across the skies in any which way that you can. And here we are coming up to the morning. So we just need to make sure that we're polar aligned. So we're currently where we are, roughly 51 degrees north. So that polar axis needs to be about 51 degrees as well. And we just need to make sure that the tracking rate is going to make sure that it permanently keeps that all into right position. These are different telescopes because why have one when you can have loads? And obviously for the different types of photography and imaging that you want to use, obviously you have to get a different telescope, and that's my story and I'm sticking to it. Please ignore the cable management in the middle picture. I know it's awful, but there we go. Things are a bit better than that now, I'm afraid. So obviously we can either use a refractor or a Schmidt-Cassegrain or a Newtonian telescope, depending on what you want to use. Obviously the simplest design is the refracting telescope, which was initially developed many years ago. And then we've gone on to more technical and more exotic designs of using Schmidt-Cassegrains and other types of ways of folding the light up into a tube to make a more compact piece of equipment to have on the telescope. And here's one of the other designs that PlaneWave do. Not that I wish to have one. And then if you get really delicated, you can have a little telescope in your own little observatory. And this is the sort of thing that I would love to get, one of these little clamshell designs, so you don't have to worry about having the slit pointing the right direction. And subsequently, you've got the whole horizon to be able to see what is available to get hold of. Very nice.
Nice.
But obviously, it all comes at a price.
Yeah.
Yeah, absolutely. Right. And this is again, we've just got, this is quite an interesting one, another one from PlaneWave. I seem to have a PlaneWave theme at the moment. This is one of their larger size telescopes, and it can track satellites. As you will see that it does move quite rapidly. It looks like something that ought to be on a boat with a Gatling gun on there as well.
That is fun.
And that is, you know, it's sort of going round, and as you can see, you've got the big Cassegrain, on the left, and then you've got two refractors on the other side to do more wide field imaging.
Is that real speed, or do you know if that's?
This is real speed. It can track very rapidly. That's not its full speed either.
My God!
But it gives you some idea of how good these are for various establishments to track satellites with.
Yeah.
So So if you want to proceed on with this, I have got a sequence of pictures, but I've disabled the sound on here, obviously for copyright issues of the music. So I'll just give you some pictures of my solar system bits. So we've got, if we'll move on from that because we all know the history and how the sun works.
Yeah.
So we obviously got some images of the sun from previous orbits of its surface, and that's an amalgamation of many days of captures there. We've got 1, 2, 3, 4, 6 days worth of images put into one. But if I do this, it gives you the idea of how it's rotating round and how they gradually spread apart and split and increase and decrease in size. So it can be quite fun there. And then we've obviously got the moon. So this will be quite an interesting comparison to what we will be getting tonight with our standstill strawberry moon tonight. So there will be lots of pictures, I expect, in the morning on the news about how this moon is appearing at various locations. So we go from various phases of the moon through to its full size, as we all know, as you've all put up with them. And then we've got Venus. Obviously, it shows the phases because it's one of the inner orbiting planets.
Did you use a filter for the one on the right? Did you use a UV filter or anything?
I've only got the usual UV-IR cut, but I have got an ultraviolet filter and an infrared filter, which can get some details of the clouds in the atmosphere. I haven't actually processed them very well at the moment, but when I do manage to, they will be in the gallery.
I think the first images of structure in the Venusian atmosphere and therefore rotation rate was from an amateur astronomer.
I'm sure there are.
Yeah.
And there are some quite good detailed structures in there from amateurs using the various filters that they have actually used. So it can be achieved. Right, so we've got Mars here. The one on the right hand side, the one on the right hand side is a slow animation of its rotation. It's not very detailed, but obviously due to the aperture telescope that I've got, so it obviously wasn't that big to start with. But we've got some details there. You can see the polar ice caps as well, and some of the other details. So
did you do that with your 5-inch?
No, I did some of that with, I mean, the one on the right hand and probably the one in the middle was probably with my C11. Okay. So I don't think Mars was all that big. It wasn't at its closest at all, but they were drawing the near oppositions that I did take them to try and get some details. Here's some earlier pictures of Jupiter that I managed to collect. And,
wow.
One of the moons there, and there's an occultation of one of the moons just about to completely disappear behind the disk there of Jupiter as well, and the red spot. Another one there with one of the moons. I'm not sure which ones are which. I have got another one with an animation of the one of the transits, but obviously not in this presentation. So this was from last year, I guess, looking at the tilt of the rings. And one over on the right hand side, I've managed to get a couple of the moons as well. So it can work out. So if you try and overexpose it slightly to get the moons, and then you just have to replace the burnt out picture of Saturn with a normally correctly exposed one to help compensate. But there have been quite a few that you've got half a dozen or more of the moons already in there. So this was one of my favorite comets from 2020. And we've also got some not too distant clouds as well at the same time. So that was quite an interesting combination of objects at the same time. Comet Neowise. This is what we call like a where's Wally, but where's Comet Neowise? So it's down over on the left hand side above the trees in the middle there. It's quite interesting to sort of give it some comparison to the local areas.
Beautiful.
And there it is, almost setting in the trees there.
Oh yeah.
Lovely. And here's a better, clearer view.
Oh.
This was just done on an ordinary DSLR camera with a 50mm lens, and they come out brilliantly.
What was your exposure time on that? Do you remember?
That was only a few seconds because of the sensitivity of the camera. So as long as it's long enough to get the image and not too long to get any star trails, you can just keep tweaking the adjustments. And here we go for this one.
Oh my.
That's lovely. The ion tails are prominent there, isn't it?
Yeah, it's come out quite nicely there.
Yeah.
Obviously, I was tracking that one for a little while because the foreground is blurred. But that was quite good. Here's Comet 2022 EZETF. You can either do it like that where you've got everything static, or there's this one which is interesting where you tell the software to keep the comet still to show its progress through the stars, and it just gives you an idea of how much movement was when you got the images all stacked together with the star trails there.
Yeah.
So this is over a 90-minute period to show you how much movement there is on this comet here.
Yeah.
And as you can see, you sort of got the foretail and the post-tail there as well. And it's interesting to compare it with that galaxy edge-on over on the right-hand side as well.
That's like Comet Arend Roland from 1957 with the prominent spike, the foretail, as you say.
Yeah. So this is just I tried to get rid of the stars there, but it gives you sort of some of the details of some of the nature of these different comets to give you. Okay, so this is a 8-minute presentation that we can do.
Thank you very much.
Would you? Right. So presentation here if you want for another time if you wish.
Yeah, I think we'll save it as time.
That's fine. That's fine.
We can save it. Save the best things till last. So,
okay.
So yes. Well, listen, Roger. Thank you very much for that, and we're glad that we were able to give you what you want, viewers, because you did ask for more astrophotography. So hopefully we can make this a regular thing, and get Roger scratching his head as to what to tell you about it. But but there are. Thank you very much, Roger. That's great. I hope viewers you found that useful. Okay. So that brings us to the end of this evening. We'll wrap things up for this evening. Derek says, thanks, Roger. That was great. Thank you, Derek. And fascinating stuff. Great images. Thanks, Roger, says Paul.
Very good.
And yeah, thanks all. And thank you all, viewers, for your contributions this evening. And Lou, I'm sure, will go quite happy that Europa Clipper has been declared the winner in the battle of the Jupiter bots. But as I said, it's they're both going to give us amazing results from the Jovian system. So
I did a quick lookup while sorry, Roger, I just spent a little time looking up some numbers during your presentation. Europa Clipper is estimated right now at $5.2 billion throughout its lifetime.
Right.
Including
5.2 billion.
Build to launch, cruise, and operation.
Was
JUICE only, and I'm doing this in dollars right now, $1.7 billion. But
Really?
there's an extra,
Ooh.
oh, now I'm converting back. Sorry, 600 million euros. So it juices actually 2.2 billion euros, which I don't know, what's that, 2.4, $2.5 billion. Something
Right.
like that. So perhaps
Hmm.
roughly juices roughly half the cost of Europa Clipper.
Oh,
Right.
I wonder why. And I've been doing some looking up as well, Lou, something we talked about. The countries who contributed towards the building of both of them.
Mhm.
So with Europa Clipper, obviously the United States was the primary contribution, but Germany, France, and Italy provided support as well. Germany for the surface dust analyzer, France for the mapping imaging spectrometer, and Italy providing support in general collaboration. And then we come to JUICE. The primary contributing ESA member states were Germany, France, Italy, the United Kingdom, and the Netherlands. But also Sweden, Switzerland, and Spain contributed to various components and instruments. And even Japan contributed to parts of the plasma wave investigation instrument for JUICE. So Europe is not just a European spacecraft. Japan contributed as well. So there we are. So that's quite interesting. But again, it just goes to show how international science is, that it's actually very rare that you will get a space launch with just one country being involved. And long may that international cooperation and collaboration continue.
Mhm.
And just a couple of things there. Somebody says that was great, Roger. Oh, that was Daz. Ignore him.
Oh, yeah.
Yeah.
Doesn't count.
No, it doesn't count. Sandra says, thanks, Roger. I learned a lot from your presentation. That is exactly what it's all about, Sandra. If you learn something, we're happy. And
Yes.
That's it, I think. And yeah, Daz says quite rightly, juice is a bargain. So there we are. Okay, we will be back next week. And can I just warn you in advance while we think about the future that in September it's Mars month here on Space Oddities. We're going to do with Mars the same that we did with the moon. We're going to do that in September. Everything you could possibly ever want to know about Mars, the planet, its position in the solar system, the exploration of it. We're going to go full out on Mars in September, a whole month of live streams and videos about the planet Mars. We hope you will join us for that and enjoy it. So until next week, we will say goodbye to you. Hope you have a fantastic week, everybody. Thank you so much for being here. Don't forget to like, subscribe, and comment if you will be so kind. And don't forget that we will be back at the same time next week. So from all of us at Space Oddities, have a fantastic week, and we'll see you next week.
Yep.
Bye-bye.
Bye all.
Bye-bye.